1, 2, 3, 4.
Electricity is the one of the most essential part of modern life. People use electricity for lighting, cooling, heating, and for operating machineries like in factories. We also use it to operate appliances and gadgets, and also in public transportation system. Without it, maybe our life won't be easy like we experiencing nowadays. It also have a big role in our economy. By the use of transformers and electric power line, we experience the benefits of electricity. We can't avoid power breakdown even if the power lines have insulator to protect it, the conductor of the power line. Due to natural made like disasters and man-made activities, power interruption happens. In this case, our group studies tracing the distribution lines and transformer using the shortest path problem. We may draw a graph with power poles and transformer as the vertices and power lines as the edges.
A graph is depicted in diagrammatic form as a set of dots or circle for the vertices. It is joined by lines or curves for the edges. In math, graph can be defined as a pictorial representation or a diagram that represents data or values in an organized manner. One of the many types of graph is a tree graph.
Tree graph. In a graph theory, a tree is an undirected graph in which any two vertices are connected by exactly one path, or equivalently, a connected acyclic undirected graph. We made a tree graph in our study in tracing faulty power lines, where the edges are the lines or cables and the vertices are the power poles with transformers. It is important on creating a tree graph because it shows the broadness of the power lines that we have studied.
An algorithm created by Edgar Dijkstra's, a Dutch computer scientist and a pioneer in his field. He created Dijkstra's algorithm and is widely used in the fields of graph theory application, especially when applying it in shortest path problem. This algorithm aims to find the shortest path from all vertex to another vertex given that the graph is a weighted graph. The algorithm behaves by checking the neighbor of an initial vertex and listing every value given in each edge and then updating the table.
Man-made. We, as human beings, make mistakes in so many ways, including making a mistake in our power lines such as this. Seems impossible to some places, right? But here's the reason. Because some trucks are big enough to damage the power lines by hooking its roof to the power line, causing it to break. And it only happens when the truck driver doesn't give enough attention to every corner of the vehicle that he is driving. And we also have this kind of incident. A very dangerous way to let a kid play a kite alone, especially when the string of the kite is made out of metal string or wire, right? Some kids are flying their kite too high because some kids doesn't have guardians when flying a kite. That's why sometimes it gets to the point that the string hooks up to the power line, causing it to break.
Natural made. One of the major reasons of power breakdown are due to natural disasters like typhoon, storms. Because of the strong winds and rain, it can damage the transformer or the power lines. Also in lightning, it can strike the power poles, and all of that can cause faulty electricity distribution that we can't prevent.
But the given data came from observations in the areas of Mexico Pampanga. A weighted acyclic graph was created to model the distribution lines and transformers. Every time a power interruption occurs, it is either caused by a faulty power line or transformer. To trace the faulty power lines and transformers, we can use the Dijkstra's algorithm by checking the voltage meter. every power line and checking whether it is in a safe range until you reach back to the service provider.
Conclusion. In this exposition paper shown that we can trace the faulty power lines or transformers to locate faulty power lines that could cause blackout and inconvenience to everyone. Using the weighted tree graph and by the use of Dijkstra's algorithm, we were able to determine the shortest path from vertex AI back to vertex A by tracing the voltage reading of its line. The researchers give two scenarios where there is a blackout occurrence due to natural phenomena and the other one was a frequent random blackout on the same area in which it resulted in line AI to O to be at 0 voltage and low reading of 220 volts respectively. After tracing the lines, we yield the result by getting the sum of the voltages 490 volts and 850 volts respectively.